Hello, hi, my name is Ian Coates. I'm your instructor there for Math 1031. Welcome to Chapter 2-1, Organizing and Presenting Qualitative Data. It's another short video, and there we go, Organizing and Presenting Qualitative Data. Once data has been collected, the next step is for it to be organized and presented visually, right? In the previous chapters there, we looked at what a variable is and qualitative and quantitative data. Here we're talking qualitative. Then we looked at types of data collection, right? So there was stratified random and just plain old random and all these kinds of ways of gathering data. And once we actually have the data, we want to organize it and let the data, the numbers sing, talk to us, right? Recall there that qualitative data is categorical. Remember the bins, right? Usually non-numerical in nature, that can neither be measured or counted. So, looking here, a table is a method of displaying data in a two-dimensional grid, organized into rows and columns. See? This test number 1, 2, 3, 4, 5, 6. Student 1 grade. The student here got a C on test 1, a D on test 2, a B on test 3, and so forth. Right? You've got the rows and the columns. A chart is a method of graphically displaying data plotted on points, lines, bars, or slices. So here we've got a bar chart showing the frequency of grades received by the 4 students on 6 different tests, right? So here we've got the frequency. This is a good graph right here to know. The whole idea, the number of students, right? So 2, 4, 6, 8, 10 students, and 6 students received an A+, 8 students received an A, 6 received a B, 2 D, 1 for D and F. Okay? We present qualitative data using a tally chart, frequency tables, pie charts, bar charts, Pareto charts, and other types of graphs as well. The majority of these there you'll need to know there for your assignment 1. These presentations are called frequency distributions, right? Just going back in here, it's all about the number, right? The number of people who have attained whatever you're looking for here. So a frequency distribution, and their purpose is simply to denote the number of occurrences of each different possible value of a variable. Good. Tally charts organize and display the raw data in multiples of 5. So, and this is a tally chart it's a frequency distribution, and you'll see there that it always goes in groups of 5. So once you have 1, 2, 3, 4, and then the 5th is a line crossed through it. So it makes it easier to count, right? 5, 10, 15, 20, 25, 30, 35, 40. 43, which is what we have here, right? There you go. That's a tally chart. Nice and easy. So frequency is the number of times a particular category or certain value occurs in a data set. Frequency distribution tables, or simply frequency tables, summarize the frequency for each category. So here, as we were saying there before, as the previous examples, frequency is the number of occurrences, and the field of interest here, this is maybe possibly number of students in dentistry, kinesiology, nursing, and pharmacy. There we go. Constructing a tally chart and frequency table. The following data shows the preferred bread type of 20 shoppers. WB, white bread, WW, whole wheat, WG, whole grain. So you just go, there's a whole grain, 2 whole grains, 3, 4, 5. So 5 whole grains, right? And then you just go in and do it for whole wheat and white bread. Okay, so Step 1, draw 3 columns to represent favorite bread, tally, and frequency. List the bread types in alphabetical order in 3 rows for column 1. Use tally marks in column 2 to count the occurrences and total the tallies and get the numbers there. And lo and behold, here we go, right? So you're taking mashed potatoes and you are organizing the data and letting it sing, letting it speak to you. And easily, you can't tell anything from here, but from here, from this frequency chart, you can see here that the majority of the correspondents chose whole wheat bread, and almost the same number chose white bread, and then there's whole grain was the least favorite. Okay? Relative frequency is the ratio of the observed frequency for each category of data to the total number of observations, n. A relative frequency distribution expresses the frequency of occurrences in each category as a decimal proportion between 0 and 1, or as a percent between 0 and 100. So, if you're going to use a decimal, 0 equates to 0%, 1 equates to 100%, so 0.5 would equal 50%. 0.75 would equal 75%. So relative frequency, category or class frequency divided by n. And there you go, F divided by n. So let's have a look at relative frequency, shall we? Using the same example here, construct a relative frequency distribution. Okay, so what do we do here? We just constructed this aspect, correct? Right? Remember your 8, 7, and 5? Well, now, there's your total. 7 divided by 20 is 0.35 or 35%. And what you're doing is you're just adding on and letting the data sing. You're letting the numbers show you even more information that we weren't privy to there before. So 35%, 25%, 40%, all written as decimals, or you could have them here as percent. You'll notice there that these numbers should add up to 1 always, or 100% always. Good, and that's exactly what we're looking at there. There may be rounding issues, but generally speaking, excuse me, there may be little rounding issues there, but it should round up to the 99.99% for the most part. A pie chart is a graph of a circle that is divided into segments or slices that represent the proportion of the pie. Okay, so just looking at here, 25% of the people chose whole grain. So you're looking at a pie chart there, right? It's 360 degrees, right? Half of a circle is 180 degrees. A quarter of a circle, 25%, is 90 degrees. So therefore, for this particular aspect, whole grain, you should be using a segment that is actually a 90-degree 1/4 of the circle, right? Pie chart's a nice visual way to demonstrate frequency distributions, okay? And you have to do one there for your assignment 1. And please remember when you are doing your assignment 1 to use a protractor, okay? Sector angle for each category is equal to relative frequency times 360 degrees. So you remember there, you get a percentage from your relative frequency distribution right in here, right? And then you multiply that percentage times 360 degrees, because 360 degrees corresponds to 100%. Okay, and in this case here, 15% of the data corresponds to 54 degrees. So easy peasy, start here, get a protractor and measure out 54 degrees. And remember there that your center should be all of these should begin at the center of the circle. Okay. So going back to our original bread example, there we go, right? There's your 25%, which is what we thought. It's a nice, beautiful 90-degree angle. White bread there was 35%. Multiply 35% times 360 degrees, you get 126 degrees. And then whole bread, whole wheat there was 40%. 40% times 360 equals 144. Okay? And this doesn't have to be here. This can be over here. This can be there. There's no rhyme or reason. But notice there that they're clearly labeled. You don't necessarily have to write on the pie chart because, you know, sometimes there you'll get little slivers. You won't be able to write. But as long as you have a legend and it's color-coded, everything is fine. A bar chart is a graph there that uses vertical or horizontal rectangles. Now this is horizontal, but they can be vertical. Makes no difference there. The width of the base of the rectangle for each category or class should be equal. And you'll notice there that they are not touching. Okay? It's not a histogram. That's a different ball game. But these are categories. Remember, we're dealing with qualitative data. These are bins, right? Which is better, whole bread or whole grain or white bread? It's not. That's not the kind of experiment here we're dealing with. They're all equally good. I can't compare them like that. I just compare them there on different choices that people have made. So the height or length of the bars are equal to the frequencies, right? And you remember there, 25% for whole grain, there's your 25%. 35% for white bread, 40% for whole wheat, and they correspond to the values there. Okay, nothing too crazy there. There's your vertical. No difference except it's straight up. This is the more commonly used aspect, the vertical, but that doesn't mean there I haven't seen many horizontal bar charts. Okay. You can even have grouped bar charts, okay, where we're now looking at two different charts on the same chart. So here we're looking at athletes, denoted there in yellow, and we have non-athletes denoted there in blue, and we've got the months of the year, Jan, Feb, March, April, May, and June, and we're just kind of grouping these guys as a comparative analysis. So in the group bar chart of number of athletes and non-athletes treated at a physiotherapy and wellness clinic from January to June. So you'll see there in January there was more non-athletes treated, but then in February and March there were more athletes treated there. Good. Let's move on. Constructing a bar chart, draw a vertical or horizontal bar chart there for the frequencies of here. So this is the grade, A, B, C, D, F. These are the number of students who attained these particular grades. So, not a problem at all, right? You've got a nice, easy peasy scale, number of your frequency on the always going in this direction here. And then on the bottom there, you have the bins or the categories. Okay? Vertical, it's kind of inverted here. You have your frequency there along the bottom, okay, and then you have the bins on the side. Myself personally, I like this. It's more easier for my eyes, but not a problem there either, okay. A Pareto chart is just a bar chart that's kind of in order, okay. Pareto charts are bar charts in which the bars are arranged in decreasing order of magnitude. If there is an other category in a Pareto chart, it is always on the right side. Okay, so we have in decreasing order, and then we have this one here, which is kind of the outlier, and it needs to be designated that, and that's why it's there on the end. So a Pareto chart is just a bar chart that is in decreasing order. Okay. Construct a Pareto chart there with this frequency table using your whole bread, your whole white and whole wheat and whole grain bread. Again, you just order them there from 8, 7, and 5, right? So you have decreasing, so you've got that characteristic look of a Pareto chart. And that is all we've got there for chapter 2.1. I know these chapters are short. I hope you guys are doing all right. That's pretty much all the information there you'll need for your assignment 1. Do let me know if you guys have any trouble. Thank you so much. Take care.